Today you're going to be recording in your journal, page 46, and we're going to be talking about very simple probability. This is just the probability that one single event will occur. It makes it very simple versus compound probability when you have more than one event occurring. And so today is simply simple probability, page 46. And so we're going to be moving over to our note page, and we will glue this on page 46 when we're done. So simple probability is the probability that any event will occur. That simple probability is that just that one simple event will occur, just one. Outcome, an outcome is basically a possible result of an experiment. And so I can have many different outcomes. We'll talk about this a little bit more, but we're going to be putting those outcomes as part of our probability. Getting a 6 when I roll a die, that's only one outcome. Could I roll a 5? Could I roll a 4? And in the video that you watched yesterday, you learned that you can't roll both a 5 and a 6, but I could roll a 5 or a 6. It just depends. And then we're going to talk about sample space. And sample space are all the possible outcomes that I have. So in the case of rolling the die, all the possible outcomes, I could roll a 1, I could roll a 2, I could roll a 3, a 4, a 5, or a 6. Now I can talk about probabilities of just one event. We're going to get into later about compound events when you're rolling more than one die. That's a little different. To find the probability of an event happening, I basically use the formula as a ratio of a comparison of the number of favorable outcomes that I want to have happen out of the number of possible outcomes that I have. For example, if we're talking again about rolling a die, and we use a die a lot, and we use flipping coins too. Find the probability of rolling an even number. So you just say to yourself, okay, I have the numbers 2, 4, and 6, and those are my even values that are possible on a die. So the probability of an even number on a dice would be equal to the number of even numbers that are on that dice over the number of numbers that I have total. So again, even numbers, I have a 2, 4, or 6. That is 3 possible outcomes out of the total number of numbers that are on the die. And there are only 6 faces, 1, 2, 3, 4, 5, and 6. If I reduce that by dividing top and bottom by 3, I can get this down to a half fraction, which is similar to flipping a coin, which is 50% or 0.5 as a decimal. And we say it's similar because it's a 1 in 2 chance. That means that if I roll the dice 2 times, at least one of those times I'm going to get a 2, 4, or 6. So the odds are better to get evens. The same thing would happen if they were odds versus evens. Odds would be the 1, 3, and then the 5. And so the same chances of evens versus odds would be very similar to flipping a coin. Find the probability of each event occurring. So the probability of getting a tails on a penny. So we talk about this. When you write it, it'd be P of the probability of tails. Now we know that on the coin, there is only one tail and one head. So that would be out of 2 possibilities. Remember, the bottom is the total number of possibilities that I have. What I want to have happen is that tail, which is only one tail out of the 2 sides on the die. So it's a 1/2. We're going to write it as a decimal, and we're going to also write it as a percentage. So remember, probability is written in 3 possible ways: fraction, decimal, or percent. Now, if we talk about sample space here for just a minute, what is the possible sample space? What could occur? So if we talk about sample space, and I'm just going to write here sample space. My sample space, and usually we put it in set notation, which is kind of like squiggle parentheses. I could get heads or I could get tails. So sample space, again, is all the possible outcomes, and that's back up here in your definition. Sample space up here are all the possible outcomes that could happen in an experiment. So if I experiment with the coin, it's either heads or tails. Probability of getting a 4 in a deck of cards. Well, you have to understand that there are 52 cards in a deck. And if you don't know this already, there are 4 suits. You have your hearts, your spades, your diamonds, and your clubs. And so in that case, there are 4 suits. So getting a 4, there's the number 4, 2 are red and 2 are black. That means that the probability of me getting a 4, and again, it's P of, because it's probability of a 4, and that's how probability looks, is 4 cards out of the 52 that are in the deck. Now, I don't know if you know this, but you can reduce 4 goes into 52, actually evenly 13 times. There are 13 cards in each suit. So there's 13 clubs, 13 spades, 13 hearts, and 13 diamonds. And so it's a 1 in 13 chance. If you were to take 1 and divide it by 13, and I'm not going to do all the math on that, but if you set it up and work it out, it's a very, very small percentage. And I'm again moving a decimal DP, moving the decimal to percentage. It goes 2 places to the right, 1, 2. That gives me 7.7%. And this is kind of rounded anyway, because 13 is a repeater. So there's our percentage. And in this spice, by the way, talking about likelihood like we were doing yesterday, this is unlikely to have happened. Over here, this 50% is equally likely, and let's add that as well here. So we have a 7.7% chance or unlikelihood that this is going to occur. If we talk about sample space, now there's times when you want to do sample space and when you don't want to do sample space. This is going to be very long-winded, and I'm not going to do the whole thing, but our sample space will be, we'll have, usually you would list this all out. And so you would have to list out all the 52 possible ways. So there's 52 outcomes in here. But just to make it shorthand, I'll put hearts, and there's 13 of those. I have diamonds, and those are my reds. And there's 13 cards of those. And that would go from your ace, your 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. And so you have to list them all out. And I'm not going to sit here and list this whole sample space out. But there's hearts, diamonds, your spades, you have 13. And then you have your clubs, which I sometimes call puppy feet. And there's 13 of those. Okay, and so that's your sample space. So probability of getting an odd number on a die. A little easier to do a sample space on this one, but we just want the odd. So going back to what we talked about with the even, the opposite of even would be odd. And so we know that the probability of getting an odd number on the die, and the odd numbers could be 1, 3, and 5. And so that's 3 possibilities out of 6. So I'm going to go down here to sample space and just talk about that for just a second. So my sample space could be that I could roll a 1, a 2, a 3, a 4, a 5, or a 6. And of the odds, that's the 1, 3, and 5 here. I'm going to underline that's 3 out of 6, which is a half fraction. And so we know this is 0.5 or 50% chance. And we know that this is equally likely to have happened. So back to this again, and back to the cards. So getting just one individual number on a card or a king, your chances aren't very good. They're very unlikely. Probability of getting a multiple of 2 on a die. Well, you have to know what multiples are. And so 2 is the first multiple of 2. And then I skip count by 2, so it'd be 4 and 6. So we're back to, again, 3 numbers here. And this is going to look like this: probability of multiple of 2. There are 1, 2, 3 possibilities out of 6, which is a half. And I'm not going to go back to listing the sample space because the sample space is the same here as it is here. And so that's just a ditto. My sample space is any of the digits 1 through 6 on a die. And again, this is going to be 0.5 or 50%. Spinners. We haven't talked a lot about spinners. And spinners in the world of probability, you want to make sure that each section has an equal chance of being spun. And so the sections generally need to be the same size. And if you take a look, you've got some reds, you've got some greens, you've got some blues here. And you can actually number them just so you know that there's 1, 2, 3, 4, 5, 6, 7, 8 sections here. So that means I have 8 possibilities, but is there a greater possibility of one color versus another? So we're going to go through and kind of look at our different colors. So probability of getting a red. So we'll start here. So probability of a red, and this is how I write it, P of red. How many reds do I have? I have 1, 2. Do I have any other ones? There's only 2 reds. So that's a possibility or a probability of 2 out of the 8 sections that I have. And I can reduce top and bottom by 2. And that'll give me a 1 in 4 chance. And 1 in 4th, if you divide 1 by 4, is a quarter, or a quarter in a pocket, or 25%. So the likelihood of me getting a red is unlikely. I have a 1 in 4 chance. That means if I spin the spinner 4 times, 1 out of the 4 times would probably be a red. Now, experimentally, that may not happen, but theoretically, that's what should possibly happen. Doesn't mean it will. So this is a 25% likelihood. Back to the sample space. If I were to list the sample space, it would be what could I possibly get? And the actual sample space is red, green, and blue. It just happens to be that you can get certain numbers of the colors there. That doesn't mean that there's 3 possibilities. You have red, you have green, 1, 2, 3 greens. So I'm going to go here to the side and write green equals 3, red equals 2, and blue, 1, 2, 3 blues. So actually my probability of the red is less than my probability of green or blue. My green and blue have equal probabilities there. So with the 8 sections, it's kind of hard. So probability of getting a blue on the spinner, and that's actually the same as the probability of getting a green. So blue is 3 out of 8. So actually in our sample space, it wouldn't just be red, green, and blue. I would probably need to list how many reds. So it'd be red, comma, red, green, comma, green, comma, green, blue, comma, blue, comma, blue, to actually get that one accurate. So I'm going to go ahead and change that, because honestly, it's supposed to be all the possible outcomes. And even though there are 3 possible outcomes, and I'm just going to use my white out here, we've got the red occurring twice. We've got the green 3 times. And you have your blue 1, 2, 3 times. And so that would give me all 8 of my possibilities or my sample space. So I really should write all of that out. So I have a 3 in 8 chance. If you take 3 and divide it by 8, you actually get 0.375. This is a fraction you needed to have memorized earlier in the year, or 37.5% because you move your decimal 2 places to the right. And again, this is unlikely. So the unlikelihood of it happening. Probability of getting a green is going to be the same percentage and still unlikely. Now, I want to talk just a minute about simple probability where you could have it. You could say, what's the probability of me getting a red or a blue? And this isn't on here, and we're going to go ahead and add it. Probability of a red or a blue. So red was 2, right? And blue was 3. So together, I would just add the spaces. So red or blue would be 5 out of 8. And 5 out of 8 has a better likelihood than 3 out of 8 does. So if we say we take 5 divided by 8, then we've got a 0.625 or 62.5% chance of happening. And this is way more likely. So me getting a red or a blue, or I could have done red or green, then the likelihood increases dramatically. So in that case, I can say red or blue. Now, the only thing I can't say, and this is where you have to be careful with your terminology, is you can't use the word and. And I'm going to put the word and here because red and blue can't happen, meaning I can't spin a red and a blue at the same time. This is simple probability. This is one event. So that's not a possibility to use the word and, but I can use the word or. We'll get into later compound events where you have something and then you have something else happening, and they're compound events. You have more than one event happening. Now, if you remember from the video that you watched with Math Antics, probabilities of each of these occurring, the red, the green, and the blue, should add up to 100% or 1 whole. And so just a reminder of that. So my probability of my red was 2 out of 8. My probability of a green is 3 out of 8. And my probability of a blue happening is 3 out of 8. And if I add those fractions together, and just a reminder, when you're adding fractions, the denominator doesn't change. And you add the numerators 2, 3, and 3, that adds up to 8. And that gives me my 1 whole, or my 100%, because those are all the possibilities that exist on my circle. So if you talk about complement and you see the word complement, the complement means something not happening. So the complement means that if it's a red or a blue, and that's 5 out of 8, the complement would be what would be left over, which is the green, probability of a green, which is 3/8. And so we know that all of these have to add up to 1 whole. So if you have the probability of one event, you want a probability of the other event, you can subtract it from a whole and find that percentage. And again, back to likelihood. All right, so that happens to be our lesson today on simple probability. And as you can probably imagine, we're going to be getting into compound probability and further into more than one event occurring. Until next time.